derivation of first derivation of first equation of motion. Derivation of first equation of motion. We know the first equation of motion is 1. First equation of motion equal to v equal to u plus at. Now, how we will derive this? First, we will take the acceleration. What is the acceleration? We know acceleration a equal to change of velocity. A equal to change of velocity per unit time divided by time per unit time divided by time. This will be equal to acceleration. So in terms of v and u, we will write down this v minus u divided by t. This is our acceleration. Now what is the acceleration? Acceleration is a equal to v minus u by t, change of velocity divided by time per unit time. So we will try to write down this. This will be equal to at equal to v minus u. Suppose a body is moving with initial velocity. A body is moving with initial velocity u, and this body will cover the distance s at time t with uniform acceleration a, and final velocity will be v equal to final velocity. So this will be equal to final velocity. Body will acquire the final velocity. The s equal to distance and t is equal to time taking. A equal to uniform acceleration. Okay, acceleration. V equal to u plus at from our acceleration formula, change of velocity with time. This will be equal to, from this we take that at equal to v minus ut. So from here, when a body moving with uniform acceleration a, initial velocity u and final velocity v, and covering the distance s at time t, then this will be equal to, we write down this v is equal to, this will be equal to, we write down this v equal to, v will be equal to u plus of at. V equal to u plus of at. This will be equal to v equal to u plus of at. This is the first equation of motion. This is the first equation of motion, which will coming from this equation, from acceleration equation. A equal to change of velocity v minus u by t by t. From this we get at equal to v minus u. From this v minus u equal to at multiplication a multiplication t at. So first equation of motion, this will be v equal to u plus at. Now what is the second equation of motion? Next we'll derive the second equation of motion. This will be the second equation of motion, s equal to ut plus of half a t square. Ut plus half a t square. S equal to ut plus half of a t square. Now we know that when a body is moving from initial velocity u to final velocity v, and at time t, uniform acceleration is a and distance covered is s. So then the average velocity will be of the body, the average velocity of the body will be a. In the average velocity of the body, this will be equal to v bar equal to v bar average velocity. This will be equal to v plus u by t. This is the average velocity of the body at time t. Then the body covered the distance, we know s. The covered the distance. So from this equation we can write down s equal to v plus u by 2 into t at time t, this will cover the distance s. So s will be equal to v plus u by 2 into t. V bar will be multiplied by the t. V bar will be multiplied by the t. তাহলে v plus u by 2 into t. So from this we will write down this s equal to v plus u by 2 into t, v plus u by t. From the first equation of motion, we know v equal to u plus at. Now put the value here, the value of the v here. So this will be equal to s equal to সুতরাং s equal to v means u plus at, v means u plus at, again plus u divided by 2 into t. So from this equation we get u, this will be equal to 2u plus at divided by 2 into t. From here we get s equal to, this will be equal to 2t, 2u t, when t will be multiplied with 2, this will be equal to 2ut by 2 plus at into t divided by 2. So from this we get this will be equal to 2 will be cancelled, this will be equal to ut plus half of a t square. This is the second equation. Means s equal to, we get s equal to ut plus of a t square. So s equal to ut plus of a t square. This is our second equation. Now we will try to derive this equation from when a body is moving with a final velocity v, initial velocity u, distance covered s, and time taken t, and a is the uniform acceleration. Then the average velocity of this body will be equal to v plus u by 2. This will be equal to s equal to, when the distance will be derived from this average velocity, then s equal to v plus u by 2 into t, which will give us the s equal to v plus u by 2 into t. So s equal to, now we will try to put down, now we will try to change the v with the first equation, v equal to u plus at. Next u plus at we will put here, u plus at plus u by 2 into t. So after calculation we get 2u plus at, 2u plus at, 2u plus at by 2 into t, then 2ut by 2 plus at into t by 2, which will give us the ut plus half of at square. This is the second equation of motion. This is the second equation of motion. Next, we try to derive the third equation of motion, which is the third equation of motion, which is derived as v square equal to u square plus twice as, whereas a is the uniform acceleration, v is the final velocity square, u is the initial velocity square, and s is the distance covered. So how we will derive this? Now we know the to derive the third equation of motion, we will first write down the second equation of motion. First we will derive the second equation of motion, which will equal to s equal to ut plus half of at square, to derive the third equation of motion, v square equal to u square plus twice as, we will write down the second equation of motion, and then we will derive this. Now the second equation of motion, we know s equal to ut plus half of a t square, ut plus half of a t square. Now from here we derive the third equation. Now s equal to ut plus half of a t square. Again we know that from the first equation we know v is equal to u plus at. From here we know that t is equal to v minus u by a. From this equation, v minus u t equal to v minus u by t. Now we will try to put this, the value of t here, equation s. So s equal to from here to here, from s equal to u t v minus u by a and plus half a t square, means v minus u by a whole square. Okay, this will be equal to u minus v minus u by a plus half of a v minus u by a whole square, which will give us the this will give us the v minus u by a, and v minus u by a, this will give us the this. Now from this we get uv, from this we get uv minus u square divided by a, and from this we get plus half of v square u square, half of a will be cancelled and there will be only one a here. A square means a will be cancelled, only a here. So we get v square minus v square minus 2 v square minus 2 uv, v square minus 2 uv. From this v square minus 2 uv plus of u square divided by a, v square minus 2 uv, v square minus 2 uv plus u square plus u square, and this will be equal to this. Okay, this is our third equation. Now we'll try to derive the third equation from here. Again we know that here we will try to LCM of this a and twice a. Where is a and twice a? Here the a and this is the twice a. We get twice a. Here is no 2, so this will be multiplied by 2 uv minus 2 u square, then this will be equal to here 2a, this will be equal to v square minus 2ab plus u square. Okay, this will be equal to 2 uv minus u square minus v square 2ab. Okay, this will be equal to 2 uv minus 2 u square minus v square plus u square, v square plus u square minus 2 ab. This will be the v square plus v square, because they had the plus. This will be the plus v square. Okay, this will be the plus, this will be the plus v square Okay, this will be the plus v square minus 2av. Again 2av and 2av will be cancelled. Okay, there will be only remaining part is 2u square will be equal to 2u square will be equal to 2u square will be equal to my v square minus u square, v square minus u square divided by twice a. So this is the equation, twice a. Now from this we get this will be equal to s equal to v square minus u square divided by twice a. Okay, now our equation will be equal to twice as equal to v square minus u square. So v square equal to u square plus twice as. This is the proof of third equation. This is the derivation of the third equation. So from here we have already calculated v square u square plus twice as, v square u square plus twice as, v square plus u square plus twice as. Again we will try to understand from this equation, when the initial velocity will be, when a body start from a rest, then the initial velocity when the body start from a rest, then the initial velocity start from a rest, then the initial velocity u equal to 0. When the body start from a rest, then when the body start from a rest, then u equal to 0. 2, when the body finally, this will be equal to 0 when the body in rest, after covering the s, this will coming to rest, then this will be this coming to rest, this will be equal to 0, and third will be equal to the a will be equal to 0. Third condition is the a will be equal to 0 when the body moving with uniform velocity. When a body moving with uniform velocity. Okay, this is our total derivation of the equation. This is our total derivation of the